Welcome to Baozi Training Lead Code Solution. If you want the best mock interview experience in North America, feel free to check us out at baozitraining.org. We're here to help you land your next big offer, whether it's in-person interview, or Zoom remote interview. So especially during this COVID-19 period. All right. Okay. Again, today we're not talking about lead code solution. We're talking about Google Kickstart coding competition. This is a plate solution. It's not what I want. I want this one, which is need to change the name. This is training solution. Okay, so the problem for today is relatively simple, so you can take a read, but essentially the problem is, so three test cases. It's like giving you an array of n elements. So for the first example, n is 4, and then you have to pick 3 elements that, in order to get them, you have to pick the 3 elements that all of them has to be equal, and then you want the minimal values you have to add on to make them all equal. So that's essentially the problem. So for example, there's 4 elements, you have to pick 3, and then what's the minimal value you have to make them all equal? So you have to pick 1, 3, and 9. So that is you have to make it more equal. You have to give it a 6 for this element. You have to give 8 to the second element, which is sum to 14. If you pick 100, then you have to give more. So that was the problem. So the thought process is relatively simple. If you start with the brute force approach, you have to essentially pick p elements from the n elements. So that gives you a CMP. So I didn't use LaTeX for this one, but this is essentially what I mean, CMP. So we all know this equals to CMP equals to n times what the CMP equals to, n times p factorial divided by p factorial, something like this. But basically it's an n factorial kind of time complexity, and that won't work for our case. And then sorting should naturally jump right into mind. So what I did for this problem essentially is I sorted all the scores from the largest element to the top from descending order. And then once you have the element sorted from the descending order, so let's say 100, wait, what was this first example? 100, 9, 3, 1, you have to pick the first 3 elements out of these 4. So what I did is, so you just assume this element is picked, the largest number of element is picked, and then you have to essentially pick the next 2 more elements from this array. Because this is the largest number, so the total you can just divide directly times the number of elements, essentially is p, and then we just have to basically know how much we have to add it, right? So in order to do that, we can keep a rolling sum. At this moment, we're very familiar with what a rolling sum is. So all I need to do is, in order to know the differences, I can use the rolling sum from here and the minus from here, so that I can get the sum of here, and then I can calculate. So in that case, the time complexity is actually very simple. It's O(n). So here's what I did. So essentially, this is the dealing with the input part. I'll skip that. So this is the main function. This looks like a leak code. So you have do some sanity check. Having the integer, there's no easier way to sort in descending order. So I have to convert it into an integer array, big integer array. And then I have my prefix sum. So doing a prefix sum thing. And then this is the for loop. So what I do is, assuming this number is the largest number you have. So you have n numbers, p numbers you have to pick. So this is the expected training time. So what is the existing training time? So you can use the prefix this minus prefix that plus this score. So this is kind of like the delta, the existing sum, and then the delta is this minus 2, and you keep a minimal one. So That's it. Relatively simple. The main thing is the time and the space complexity is all in terms of n, and this is essentially using sort and array and a rolling sum. That's it. Thank you very much, guys. Try it out. I'll see you guys next time.